This is problem number 10 from Homework Sec 5 from the Math 216 web work. I'm mostly doing this just so I don't forget how to do this myself because the book does a terrible job of explaining this problem. It took me forever how to figure out how to do it by myself. So I will clear this off. Actually, first thing we want to notice is M1 and M2 here are both 1. Therefore, we can basically ignore it. Makes it very convenient. So our A matrix will just be this matrix right here. Now I'll clear all of it off. Well, the two equations that we end up getting are x1 double prime equals negative 10x1 plus 6x2 plus the forcing function 2 cosine of 6t. And then x2 double prime equals 6x1 minus 10x2 with no forcing function. Now the first step that we'll take is to find the free or natural oscillation solution, which means no forcing. I will erase this for now. No forcing. Now, this is a pretty simple system to solve. We can write our A matrix, which will be negative 10, 6, 6, and negative 10. We can put it in the form 0 equals determinant negative 10 minus lambda 6, 6, negative 10 minus lambda. And after computing this, we will get lambda squared plus 20 lambda plus 64 equals 0. And after we factor that out, pretty simple, we get lambda equals negative 16 and lambda equals negative 4. Now notice that we want a periodic solution because these are blocks oscillating back and forth. That means that we will set lambda equal to negative frequency squared, and we will thus get omega equals 4 and omega equals 2. Now at this point we have two frequencies, and if you remember, our forcing function had a frequency of 6 because it was 2 cosine of 60. And that means at the end, our final solution will be a superposition of 3 frequencies. Now, clean this up. At this point, we have our eigenvectors. That means we can find our we have our eigenvalues, and we can find our eigenvectors as normal. I guess I'll do it in a different color. First, we can consider the case lambda equals negative 16. And what will we get? We will, after subtracting the lambdas from A, we will get all 6's equals 0. And after solving that, we get our eigenvector is equal to 1, 1. And similarly, for lambda equals negative 4, we get negative 6, 6, negative 6. Nope. This should be a 6 and negative 6. AB equals 0. And our eigenvector becomes 1 and negative 1. At this point, we have enough information to write out our free or natural solution. We can write it at the bottom. Free solution. And we'll say that that equals x. Remember, this is the vector x. It encompasses x1 and x2. Our x is equal to C1, arbitrary constant, cosine of 4t, plus C2, sine of 4t, and then this was multiplied by the eigenvector 1, negative 1, plus C3 cosine of 2t plus C4 sine of 2t multiplied by eigenvector 1, 1. That is our free solution. Now that we have a free solution, we want to find our particular solution where we insert our forcing function back. I will clear this off. We don't need this anymore. We found our free solution. Now, if I insert the forcing function back, which is 2 cosine of 6t. Now, to find the particular solution, the first thing we do is to assume that our solution is of the form, I'm getting ahead of myself. Our solution is of the form x1 and x2 are equal to two arbitrary constants, c5 and c6, times cosine of 6t to match our forcing frequency. Now that we have our anticipated solution form, we can plug this back into our original equations to get negative 36 C5 C6 equals 10 6 6 negative 10 C5 C6 plus 2 0. Now I suppose I should explain where I got this expression here. Now, where I got this expression is when I converted x1 double prime and x2 double prime into matrix form, and doing that we would get x1 x2 double prime equals matrix negative 10 6 6 negative 10 times x1 x2 plus 2 0. This looks like 6. 2 0 cosine of 6t. Now, after plugging in my anticipated solution form, c5 c6 cosine of 6t, the cosine of 6t's drop out, leaving us with this expression here. And from here, all we do is rearrange. Now, after rearranging, we get the expression. We move the 2 0 to the other side and get equals the A matrix plus 36 remember this is a scalar, so we have to multiply by the identity matrix, 36i times C5 and C6. And then from here, we can further simplify, and we get -2, 0 equals 6, 6, 6, 26. Should make this neater. And times C5, C6. And this is pretty easy to solve. After solving, we get C5 is equal to -0.08125. C6 is equal to 0.01875. And thus we have our particular solution now, which is x is equal to C5 and then C6 times cosine of 6t. This is our particular solution. Now that we have our free solution and our particular solution, we can rewrite both expressions as one complete general solution for the behavior of the system. And what is that? We get x of t is equal to C1 cosine of 4t plus C2 sine of 4t times 1 - 1 plus C3 cosine of 2t plus C4 sine of 2t and then plus the particular solution, cosine of 6t -0.08125 0.01875. This is the general form of our general solution. And from here, we're given that x1 at time t equals 0 is equal to x2 at time t equals 0 equal to 0. Similarly, their derivatives at time t equals 0 are this 0 as well. Now we have 4 variables and 4 unknowns, or I should say 4 initial conditions and 4 unknowns, and we can solve for C1, C2, C3, and C4. What you'll get in the end is C2 and C4 are both equal to 0. This isn't surprising because there is no first derivative in our equations, so our sign terms just drop out. You get C2 equals C4 equals 0, and C3 is equal to 0.03125, and C1 equals 0.05. And we would plug C1 through C4 back into our general solution to get our final answer. That is it.